In today's modern world, your border is the interface between yourself and the end user. Businesses today not only need an online presence, but need to ensure they can deal with an ever-increasing hostile environment. But as attacks shift towards the application layer, is traditional security enough? In this session, I'll illustrate how you can leverage AWS development services in conjunction with the wider AWS platform to create an architecture that dynamically responds to what is occurring in your environment, allowing you to build a self-defending border to protect your online assets. Let's quickly talk about the state of play in business today. In this ever-increasing digital world, the frequency of attacks are increasing year on year. But at the same time, the attack vectors are becoming more and more complex. Businesses are often prolonging and extending out their security investments, sweating out their assets. There are more rules and regulations that need to be adhered to. And let's face it, it can be difficult to be compliant. And lastly, we have a plethora of disparate, disconnected systems that we really struggle to extract value from. So, what are the threats facing today's online websites? Look, there are many. So, whilst we could talk about them, the king of the application layer-based attacks is the Open Web Application Security Project-style attacks. The OWASP Top 10 was last updated in 2017. And it's no surprise that number one on the list is injection. Injection occurs when a malicious actor can send hostile data to an interpreter. Injection can result in data loss, corruption of data, and in some cases, complete host takeover. This is serious stuff that we need to be mitigating against. Let's take a look at this simplistic example here, where I've decided to log into a website. I've entered in my username and password, which is translated into the following T-SQL query against the database engine. And it might look something like this. Pretty innocent. But we know not everyone is innocent. And by not validating our user input, in this scenario, our malicious actor has been able to return all usernames and passwords as a record set. Obviously, this would require a bit of massaging to return as HTML, but you get the idea. So how are we fighting these threats today? And wearing our traditional security hat, we're going to be using controls. And we have various controls available to us to provide countermeasures. But there are problems. These traditional approaches do not scale versus effort versus return. Firstly, these proprietary systems are often incredibly expensive, requiring large upfront costs, as well as the use of professional services for implementation. But more importantly, businesses the world over are adopting a DevOps methodology. And these businesses rely on automated deployments. And they often see an opportunity to automate security as well, DevSecOps. But these traditional approaches often lack a multi-vendor integration. And lastly, if your site has a high release cadence, how often is security getting in the way of genuine transactions? So enough theory here. Let's make this real. Let me introduce you to the Snowy Unicorn Elevator Company. Their website is based on the popular commercial off-the-shelf software WordPress. But they've modified it extensively to work with their ERP and CRM platforms. It's a two-tier stack with Apache on the front end and MySQL on the back end. And to ensure deployed capacity matches user demand, their front end is deployed in an auto-scaling group. On the back end, their MySQL database is spread over multiple availability zones in order to provide HA. They also have a Bastion host, which is used for remote administrative purposes. They have just invented a revolutionary new type of elevator that has thrust them into the digital era. And because of this, traffic to their website is exploding. It's growing by orders of magnitude month on month. But with IT not being their core business function, their security posture could be described as, at best, block and tackle. They are reactive. They make manual firewall changes, do nothing with their log artifacts, and recently received an email ransom stating they need to pay 100 Bitcoins by Sunday or their site will be taken offline. What will they do? I hope none of this sounds familiar to anyone here. All right, so today I'll be leveraging Kali Linux as it will form the basis of our attacks. For those who are not familiar with Kali Linux is a Debian-derived Linux distribution perfect for penetration testing and forensic auditing. It contains several hundred tools perfect for prodding and poking other systems. It's available in 32-bit, 64-bit, and ARM architectures, and you can find it in the AWS marketplace as I am today. So wearing my attacker's hat, what attacks will I be performing? Well, the first thing I need to do is some discovery. I need to understand what I'm working with here. I'm looking for breadcrumbs of information, HTTP headers, script engine versions, directory structures, and so on. I'm then going to crawl and extract as much information as I can, perhaps for a future phishing campaign on their customers. I'll perform some OWASP-style attacks. I'll add a serving of denial of service, and the cherry on top, a brute force attack. Can we switch to the demo, please? All right, so here we are in Firefox taking a look at their website. As I mentioned earlier, it's a two-tier stack with Apache on the front end and MySQL on the back end. And given that WordPress constitutes over 30% of websites worldwide, this should hopefully have synergies to many of the websites you manage and keep secure today. So the first thing we're going to do is perform a scrape of this website. I have multiple SSH sessions open to the same Kali Linux instance, and I've crafted a scraping script. Let's take a quick look. As we can see, it's using curl and wget, nothing too special here. So let's kick this off. And whilst it's running, let's go back and look at their robots file. And based on their robots file, to me, this is a pretty clear indicator that it is WordPress, based on the wp-admin. If you're not familiar with WordPress, it doesn't matter, because this is something you can put into your search engine to quickly ascertain. So I think they're running WordPress. I'm not sure. It could be an old robots file. So what I can do is leverage the WordPress vulnerability scanner, which is part of Kali Linux. But WP scan can take some time to run. And given we're time limited today, we've run this just before the session. And what I can deduce based on the output of WP scan is their PHP version is 7.016. Their WordPress version is 4.79. So they're a little bit behind on WordPress patching. There's a vulnerability in all versions of WordPress less than or equal to 4.94. So the current version is 4.95. They have a theme and a plugin installed. And the plugin that was detected is called Apartment Management. Now, Apartment Management is a WordPress plugin designed to manage building maintenance tasks. The Snowy Unicorn Elevator Company have repurposed this plugin, not to manage building maintenance tasks, but to manage their elevators. And one of the functions of this plugin is the ability to send private messages. If anyone can decode this, please come and see me after this session. So why am I showing you this? Well, whilst WP Scan doesn't think this plugin is vulnerable, I do. And I've crafted some pretty interesting queries. Shall we try this? So we're going to perform a multi-stage SQL injection. So it's not as simple as running this directly against MySQL because, MySQL is not publicly accessible. Port 3306 is not listening. So I need an injection vector, and that is going to be Apartment Management. And it gets more complex. I need to have a multi-field, multi-row record set return as a single field with a single row. So we'll execute this. So what we've been able to do here is list all tables contained within their WordPress database. And one table really stands out to me. That is the accounts table, as it doesn't have the same WP underscore prefix as the other tables. So I'd like to understand a little bit more about this table. So I'm going to take a look at the information schema, and of course, the query is encoded. And based on the information schema, I can deem what fields are contained within this table. So we can see it contains 3 fields: name, date of birth, and address. And now, since I know what fields are contained within this table, we can run our last query, which is going to extract all their information out of their database table. So they've gone from having an OK day to having a terrible day. Personal identifiable information, including first names, last names, date of birth, and addresses, were just exposed. Now, I mentioned before that there was a vulnerability in WordPress versions less than or equal to 4.94. Given 4.95 is the current version, and everyone may not be on that build, I'm not going to disclose too much information about what I'm doing here. But suffice to say, for a very small payload that I'm sending, Apache is having to respond back with a large payload. It's close to 8 megabytes in size. So even if I can't take this site offline, I can increase their outbound bandwidth by hundreds of megabits per second. So we're going to jump back into Firefox and refresh the page. And what I hope will happen is their website will go slow, come to a crawl, and then eventually just give up. Well, look, it's not loading. I'm hoping to see a timeout page, but given we're time limited today, let's just move on. So I mentioned earlier they have a Bastion host. Now, I know it's not possible to query a DNS zone for an A record that you're not familiar with, but in the wild west of the internet, IP scans with TCP IP fingerprinting occur at disturbingly high rates. So we've just run Nmap here, and we can see that port 3389 is open. And for those who aren't familiar, port 3389 is used by Remote Desktop Protocol, which is a protocol used to manage Windows servers remotely. I'm leveraging Hydra, which again is part of Kali Linux. Hydra is a brute force attack tool. I've downloaded a password file containing 2.1 million passwords. I'm assuming the standard Windows administrator username, and we're just going to iterate through this. Can we quickly switch back to Firefox? So eventually it timed out. So their website and all nodes in their auto-scaling group became unhealthy very quickly. Can we switch back to the deck, please? So what did you think of their website? All the trademarks of an expert UI design team, right? Look, for a business relying on its online presence, one guy with a laptop in 10 minutes has caused chaos. Their website is currently offline. They cannot manage orders. They cannot manage maintenance requests. Personal identifiable information was just breached. And with the increase in data breach notification laws around the world, this could have really serious consequences for them. But what's really scary is this all flew under the radar. I didn't invite you here today to focus on building a better candle. Absolutely not. We're here today to learn how to build a light bulb, self-defending borders. So we have some new architecture here. And before we jump into some more demos, let's trace how the traffic is going to flow. At the heart of our self-defending architecture is AWS WAF, but more specifically the Web ACL, which acts as a central inspection and decisioning point for all incoming traffic. The inherent protective functions of this architecture will determine what rules get dynamically applied into AWS WAF and AWS other services. Our website is now resolving to an Amazon CloudFront distribution, which is being protected by AWS Shield to allow only port 80 and 443 traffic. CloudFront is handling both static and dynamic content, and for content that cannot be served at the edge, it's being retrieved from our origin, which is our application load balancer. And to further increase our security posture, our application load balancer is set as such to only accept incoming requests originating from Amazon CloudFront. Just as the saying goes, if you're not keeping score, it's just practice. All logs generated by CloudFront, our application load balancer, and Apache are being pushed into an Amazon S3 bucket and ingested by our architecture. And lastly, we have our honeypot endpoint, which is a security mechanism designed to lure and deflect incoming attacks. I chose WordPress today, not only because it's popular, but because there is plenty of collateral available online on how to deface and compromise an unpatched, unsupported version of WordPress. Our honeypot will detect inbound requests from content scrapers and bad bots that don't obey our robots file, as well as those trying to access known application exploits, and then we will take action. I'm going to pause here and change gears, because this is where this session gets real. We all know that AWS provides a suite of best-of-breed security services. But we also provide a portfolio of building blocks that allows you to architect and develop robust security architectures. There's Amazon SQS and Amazon SNS, our fully managed queuing and messaging platforms to help decouple your architectures. There's Amazon S3 and Amazon DynamoDB, our scalable and durable storage platforms, perfect for audit trails and logs. And I've listed quite a few non-security related services here. And that's not a mistake. And that's because in 2018, security can no longer be looked at in isolation. And it is these services that really empower you to build modern, robust architectures. The key to adding smarts into our border today is the use of AWS Step Functions and AWS Lambda. These two services are providing us a capability not only to manipulate AWS services and other services, but a function to prevent false positives of business-critical applications. Now, it's dev days today. We're all builders. So I'm going to assume that we're all relatively up to speed on Lambda. But there may be a few of us in the room today that aren't that familiar with Step Functions. So let's jump to a quick overview. AWS Step Functions is part of the AWS Serverless platform, and it makes it easy to coordinate Lambda functions for serverless applications. If you look at your portfolio of apps today, I bet there aren't too many applications that have one module, one function, one endpoint. In fact, it's common to have lots of functions, and that's where Step Functions comes in. Step Functions is a reliable way to step through the functions of your application to ensure it runs in the order as specified. And if an issue does occur, you can quickly hone in and debug. Step Function supports the following states today, and you can add more, and we'll be adding more in the future. With so many states available, you can build some really, really interesting state machines. Using the Amazon States language, you define your state machine in JSON, which is then visualized in the console. Your state machine consists of a series of steps and transitions between each step. When you start your state machine, you provide JSON, and this JSON blob gets modified as it transitions between states in your state machine. Today, I'm using Step Functions as a common architectural pattern, but I want to quickly talk you through the use case with our honeypot. And it all starts when a request is made to our honeypot endpoint. API Gateway is accepting this and proxying the request through to our Lambda function. Our Lambda function is extracting the IP address and HTTP user agent and passing this information into our state machine. And the first thing our state machine is going to do today is try and figure out, have I seen this attack before? And it does so by comparing the user agent against the DynamoDB table. If there's a user agent match, we'll automatically add the IP address into AWS WAF. Otherwise, we're going to contact our InfoSec team. We're going to pause. We're going to ask them to manually review this. And assuming that they believe this is to be a malicious attack, we're going to add the user agent back into DynamoDB and the IP address into AWS WAF. What I've built here is a reusable and extendable pattern that could be modified to have multiple inputs driving multiple outputs. If you'd like some more information about the manual approval process in this state machine, I've left a great link in the session summary, so if you tap your badge on the way out, you'll be sure to receive it. Can we switch to the demo? All right, so here we are back in Firefox. We've got the same website, different URL, same robots file, but don't take my word for it. Let's jump into our IDE and div the results of WP scan. So on the left, in red, we have our original architecture. On the right, we have our self-defending architecture. We still have the same version of PHP, the same vulnerabilities, the same theme, the same plugin, just a different URL. But did you notice anything else? We now have Amazon CloudFront in the headers, and by virtue of using Amazon Route 53, we are now protected against all known layer 3 and 4 attacks via AWS Shield Basic. Before, I was pretty successful in launching a multi-stage SQL injection. That took me probably the better part of a day, if I'm being honest. So let's try and rerun the same SQL injection against our self-defending architecture. So they've gone from having a terrible day to being able to block, detect, and take programmatic action. All right, so that didn't work. WP Scan still believes that this site is vulnerable for denial of service. So we're running the same denial of service script, this time targeting our self-defending architecture. And in order to quantify the site performance, let's leverage Firefox Inspector. And reload this page. So not only is their website online, but it is still extremely performant, and that is because Shield Standard and CloudFront are dropping these requests at one of our 120+ edge locations. So let's stop that. So before, I was able to scrape their website. So we're going to try and rerun this again. Same script, different endpoint. So whilst this is running, let's jump back into Firefox and take a look at their robots file. And based on their robots file, there are various directories that compliant scripts and spiders should stay well clear of. But the thing is, I'm a scraper. I just don't care. So my script is trying to hoover up all bits of information on their site. All right, so my phone has just started vibrating. It looks like I've received a message. So I alluded earlier to the use of Amazon Simple Notification Service. Today, I'm using Amazon Simple Notification Service in a fan-out pattern, not only to send messages to my phone, but to email as well. So we're going to jump into our email here. And we've received an email stating that our honeypot has been hit. We've got the IP address and the user agent. But what this has also done has started an active state machine. Can we zoom the level, please? So if we look at the input of this state machine, we can see we have the IP address being passed in, the user agent, and some other arbitrary details. And we're currently in a manual approval process, as indicated by the box in blue. And the reason why we're in a manual approval process is because we haven't seen this attack vector before. So if we drop back to Kali Linux and take a look at DynamoDB, if we drop to Kali Linux, we can validate this has taken place by looking at the results of wget. So API Gateway has proxied the request through to our Lambda function, which is returning the message, thanks for the visit, a bit cheeky, and the IP address. And we can validate that also by looking at a DynamoDB table. So I'm just using the AWS CLI here, and I'm trying to look for the user agent, wget 1.19.4, no records. And that is why we're in a manual approval process. So if we jump back into our email, we're going to click Approve. The result is going to flow back through API Gateway. The task token is going to be passed into our state machine. It's going to execute the Lambda function update WAF badbot ACL. And I can validate that has taken place in a few ways. I can take a look at AWS WAF via the CLI console or SDK, and our IP address is now listed. I can also go back to Kali Linux and take a look at our DynamoDB table, which now, hopefully, is returning a record. As we can see, wget 1.194 is being returned. So subsequent attacks will now be detected. But I can just rerun our scraping script again. So rather than taking minutes to run, returning HTTP 200s, this should now just take a short few seconds and return 404s. Can we switch back to the slides, please? So we just saw this in action, but let's dive a little bit deeper into our manual approval process. With step functions, you need an invocation method. This could be a scheduled event, or it could be the result of something occurring in your environment. Today, it's API Gateway, proxying the request through to our Lambda function, which is calling our state machine. Our state machine is calling back to Lambda using a long poll task. The get activity task is used by workers to retrieve a list of tasks which have been scheduled for execution by the running state machine. Lambda is then generating our email. And when it generates this email, it's including the state machine task token. The task token identifies the running state machine. Once the user clicks either approve or deny, the task token and the result, send task success, send task failure, is being sent back through API Gateway, back via Lambda and into our state machine, which continues doing what it needs to do. A development principle is to always use feedback loops. And that's how I like to think of this last function. It's a safety net should my previous attempts not be successful. I've added in another AWS service, AWS Guard Duty. AWS Guard Duty is a fully managed threat detection service that continuously monitors your AWS account for suspicious or inconsistent activity. And it does so by looking for unusual API calls, detects compromised EC2 instances, or those performing reconnaissance on your account. So what value is Guard Duty providing us today? Well, Guard Duty is feeding our step function state machine the IPs who manage to hit us with inconsistent usage patterns, as well as those IPs originating from third-party IP reputation lists, such as a Tor exit node list, Spamhaus, or Proofpoint's drop list, to which we will then take action. Guard duty results are available via CloudWatch. So not only can you detect, but you can report and act via CloudWatch events. Today, I'm using step functions and Lambda, but you could very well much use SNS to send this to a SIEM or SOC. With so many choices, you really have the world at your fingertips. Can we switch back to the demo? So in the very first demonstration, I launched a brute force attack. And probably a few moments ago, my phone started vibrating in my pocket again. But rather than have a look at my phone, let's just jump into my email here. And we can see our IP address has been detected performing an RDP brute force attack. So I've grabbed this JSON payload from guard duty, I've massaged it through my state machine, and here we are in our email. But what this has also done, it started another state machine. But this time, we're not manipulating AWS WAF, we're manipulating the EC2 guest firewall. Now, we're nearing our time together today. I really hope you don't believe this session is smoke and mirrors, but just in case you do, let's try and telnet in. And we can see we've been able to telnet into our Bastion host on port 3389. So let's jump back to our email. We're going to click approve. It's going to flow back through API gateway, back into Lambda, back into our state machine, and execute our next Lambda function, update EC2 guest firewall. OK, so that's now taken place. So now let's try and re-telnet back in. And just like that, we have leveraged a guard duty finding to drive orchestration within our environment. Can we switch back to the slides? So let's recap what we just saw. We have climbed the curve. We have taken the Snowy Unicorn Elevator Company from an architecture that was reactive, provided little to no visibility, into one that is self-defending and drives maturity within their organization. And we've done this not only by leveraging traditional security services, but by leveraging the services you see above. Services that were once the realm of architects and developers have augmented our architecture, providing us a pattern that will not only work for today, but scale for tomorrow, and all at the same time reducing our administrative overhead. Please see the following links to help you get started on Lambda, step functions, and I've included 2 blog posts to WAF Lambda automation and our step functions manual approval workflow. There's no need to take photos of this slide because as you scan your badge on the way out, you'll receive these electronically. Before you leave today, please ensure you rate this session as feedback is important to us and it helps drive the future selection of other sessions. And finally, I'd like to say a big thank you to Marcus Santos here, who was instrumental in the build-out and execution of this session. Thank you for attending this session, and if you have any further questions, I'll hang around to answer them. Thank you.